In the last video, we learned a little bit about what a chiral molecule or what a chiral carbon or a chiral atom is. What I want to do in this video is go through a bunch of examples and see if we can identify if there are any chiral atoms, and to also see if we're dealing with a chiral molecule. So let's look at our examples here. So here I have, what is this? This is chlorocyclopentane. So the first question is, do we have any chiral atoms? And when we look at our definition that we thought of chiral atoms, and it all comes from this notion of handedness and not being able to be superimposable on your mirror image. But we said that they're usually carbons bonded to 4 different groups. So let's see, do we have any carbons here bonded to 4 different groups? Well, all the CH2s, they're bonded to another CH2 and then 2 H's. I could draw it like this, H and H. So they're bonded to 2 of the same group. So none of these CH2s, are good candidates for being a chiral center or a chiral carbon. They're both bonded to, or all of them are bonded to 2 hydrogens and then 2 other very similar looking CH2 groups. Although you have to look at the entire group that it's bonded to, but they're all definitely bonded to 2 hydrogens. So it's not 4 different groups. If we look at this CH right here, we could separate it out like this. We could separate the H out like this. And so it's bonded to a hydrogen. This carbon is bonded to a chlorine. And then it's bonded to, well, it's not clear when you look at it right from the get-go whether this group is different than this group. But if you go around, if you were to kind of split, if you were to split it halfway like this, or maybe another better way to think about it is if you were to go around this molecule in that direction, the counterclockwise direction, you would encounter a CH2 group, and then you would encounter a CH2 group, and then you would encounter a third, then you would encounter a fourth CH2 group, then you'd come back to where you were before. So you would encounter 4 CH2s, and then you'd come back to where you were before. If you go in this direction, what happens? You encounter 1, 2, 3, 4 CH2s, and you come back to where that you were before. So all of this, kind of this bottom group, depending on how far you want to extend it, and this top group are really the same group. So this is not a chiral center. Not a chiral center, or not a chiral carbon. It's not bonded to 4 different groups. And this is also not a chiral molecule because it does not have a chiral center. And to see that it's not a chiral molecule, let me see if I can backtrack this back to the way I wrote it right before. To see that it's not a chiral molecule, there's a couple of ways you could think about it. The easiest way, or the way my brain likes to think about it, is just to think about its mirror image. Its mirror image will look like this. So if that's the mirror, you would have a chlorine, and then you have CH, CH2, CH2, and you have a CH2, CH2, and then you complete your cyclopentane. Now in this situation, is there any way to rotate this to get this over there? Well, if you just took this molecule right here, and you just rotated it 180 degrees, if you just rotated this 180 degrees, what would it look like? If you just complete, well, maybe a little over, yeah, well, not quite 180 degrees, but if you were to rotate it so that the chlorine goes about that far, you would get this exact molecule. You would get something. It would look a little bit different. It would look like this. Let me see if I can do it justice. It would look like this. You would have a CH2. So let me do it up here where we have a little bit more space. If I were to rotate this about that far, I would get a CH. You get the chlorine, and then you have your CH2, and then you have another CH, CH2, CH2, and then you would have your CH2 up there. If you were to rotate this all the way around, or actually this is almost 180 degrees, it would look like this. And the only difference between this and this is just how we drew this bond here. I could have easily, instead of drawing that bond like that, I could draw it facing up like that. And these are the exact same molecule. So this molecule is also not chiral. Now let's go to this one over here. So I have so what is this? This is bromochlorine. chlorofluoromethane, just to practice our naming a little bit. But it's very clear that we are bonded to 4 different groups. All of the different groups, or the atoms in this case, that are bonded to this carbon are different. So this carbon is a chiral center, and it should also be pretty clear that it is not, it is also a chiral molecule. If you were to take its mirror image, and this is very similar to the example we did in the first video on chirality, but its mirror image will look like this. You have the bromine on the right now. The hydrogen is still in back, and then you have the fluorine above it. No matter how you try to rotate this thing, if you try to get the bromine all the way over there, all the way to that position, then the hydrogen would be in this position, and the chlorine would be in that position. And no matter how you try to flip this around or rotate it or shift it, you will never be able to superimpose this molecule on that molecule right there. So that is a chiral center, and this is a chiral molecule. Chiral molecule. And there's a word for these two versions. These two versions, and we're going to go into the naming of them later on. It's a little bit more involved. We'll have a whole separate video on it. But these two versions of bromochlorofluoromethane, they sometimes have different chemical properties, and these are called enantiomers. Enantiomers. And enantiomers are just the mirror images. Each enantiomer is a mirror image of each other, but they are stereoisomers. So they are this is all just terminology. Stereoisomers. You're familiar with the word isomer. An isomer just means that you have the same atoms in your molecule, but then you have different types of isomers. You have constitutional isomers that say, okay, different things are connected to different things. Stereoisomers are the same things, are all connected to the same things. You have a carbon connected to only a fluorine, a chlorine connected to the carbon, a hydrogen connected to the carbon, a bromine connected to the carbon. So all of the same things are connected to the same things, but they're three-dimensional configuration. That's where we're dealing with the stereo part. Stereochemistry is the study of three-dimensional chemistry, as essentially understanding the actual three-dimensional structure of things. So stereoisomers mean that we have the same constituents, the same atoms. They have the same they have the same connections to each other. Bromine is still connected to carbon, which is still connected to hydrogen. That's all true over here. But their three-dimensional orientation is still different. And in this case, where they are mirror images of each other, we call them enantiomers. Enantiomers. And I should probably make one clarification. In the last few videos, I've been a little bit, sometimes I'll say configuration, and sometimes I'll use the word conformation. So sometimes I'll use the word configuration, and sometimes I use the word conformation. And I actually should be a little bit more, or I should have been, a little bit more exact about these. When you're talking about a configuration, you're actually talking about a different structure. To go from one configuration to another configuration, you would actually have to break bonds and kind of reassemble them. So these are different configurations, because in order for them to be able to be the same thing, you would have to swap maybe the bromine and the hydrogen in there where they are relative to the carbon. So these are different configurations. Conformations are really just different shapes or different orientations of the same molecule. So when we talked about cyclohexane being in a boat, so this is cyclohexane being in a boat conformation, or this is the cyclohexane being in a chair conformation. It's the exact same molecule with the exact same connections. We didn't detach any bonds or reattach any bonds. They just flipped around a little bit. So these are two different conformations. These are two different configurations. To go from one configuration to another, you have to rearrange bonds. Now let's look at this molecule over here. Can we identify any stereo centers or chiral carbons or chiral atoms? And you have this carbon right here. See, this carbon right here, it's bonded to a chlorine, a hydrogen, a bromine, and then another carbon. So this is bonded to 4 different things. So this is a chiral carbon, and sometimes they put little asterisks there. But if we look at this carbon right here, well, it's bonded to a fluorine, another carbon, but it's bonded to it's bonded to 2 hydrogens. So it's not chiral. It has 2 of the same things that it's bonded to. And you can even see a little axis of symmetry through it. If you look at that, you can kind of flip it over, and it's going to be the same thing. But this one right here, that is a chiral center. that is a chiral center or chiral carbon or chiral atom or asymmetric carbon. You'll see it used in different ways. And because this molecule has got that chiral center, you'll see that if you were to take its mirror image, it would be an enantiomer. This is not superimposable on its mirror image. We could even try to draw it. And just to show you don't always have to do the mirror image on the right side, we could draw the mirror image on the left side. So if we were to draw its mirror image, it would look like this. You would have a fluorine, carbon, carbon, chlorine. You have your two hydrogens. And then you would have a hydrogen here. And then you would have your bromine here. No matter what you try to do, if you try to flip this around or whatever, you will never be able to superimpose this on top of this. So these are enantiomers. These are both stereoisomers, really, relative to each other. And either of these, regardless of which one you pick, are chiral molecules. So these are chiral molecules. I'm over the time that I normally want to go in a video. So in the next video, I'll do even more examples of this.